And welcome back. All right, Nelson, so let's go ahead and continue with putting this together.
Yeah, so we're going to be using, or at least going over, one of the ANTLR features that is going to make it possible to actually inject the code into our parser that will interact with our value builders.
Okay.
The first step is to actually add a member to this class, to our parser class. And ANTLR provides us a way to do that. We can simply do member up at the top, at symbol member, and then open up a block. And now we can place members that will be added to our class. So I'm going to do iValueBuilder. But there's going to be a small problem with this code right here. To demonstrate this problem, I'm going to go ahead and launch our little app so we can get a recompilation of the entire project, or the G file. So you see how it's watching basic JSON.g. I'm going to go ahead and hit space and then Control S. See that changed and it compiled. So ANTLR is good to go. But if I hit Control Shift B, we'll have a successful build. The reason we have a successful build is because of something that went wrong. Our iValue builder is not actually being added anywhere. So let's try that compilation again. And hit Control Shift B. We still get success. Did it add to our Lexer? No, it didn't. It's not actually adding it to anything right now. Well, that's just not very good. Let's verify that the builder's actually building something. And it is. It's just kind of ignoring our member, because it's not member, it's members.
Aha.
So that's why. So now that we have successfully written correct ANTLR code, we will now have a property called iValueBuilder, or field called iValueBuilder in our parser. But if we look at it, there's a small problem. That problem is this namespace has not been included in this file. Now, I really do not want to preface every single type that we are going to be using in our builder library with console application 117 dot. So ANTLR gives us another neat little trick called header. A header block will write C# code immediately at the top of the file. So if we go ahead and add a using console application 117.abstract and console application 117.builders, Control S, wait for the recompile, it just happened. You'll notice that we now have this nice header here. And if we do Control Shift B, we'll get a successful build.
Nice.
So those are two directives that we can use within ANTLR to actually insert some code into different areas of our compiled class. So now I'm going to talk a little bit about return values, and that's where things are going to get very odd looking. Because remember, each one of these parser rules corresponds to a method, and in C#, methods have return types. And ANTLR allows us to actually define what return types our methods have and to actually set the return values and retrieve them from other rules. Now you have to remember that this is a recursive descent parser, just like the parsers we wrote by hand. So there could be, the way that the return values work, we really don't want to ever use the members section to represent anything but a top-level construct, because we want to support nested values, nested objects, nested object properties, and so on. So I'm going to go ahead and I'm going to tackle a few of the different things that we can do here with just return values. First thing I'm going to do is I'm going to change up our value rule definition a little bit. Now, our value definition, remember, this is going to be recursive, and a value represents either a constant, an object, or an array. So I'm going to have our value return an iValueBuilder. Now, here's where things get interesting. In ANTLR, you have to name your return value. So I'm going to say iValueBuilder, builder. The reason you name your return value is in ANTLR you can have as many return values as you want for a particular rule. ANTLR will actually go out and generate a little class for us that represents this, this set of return values so that we can return any number of named arguments, which is pretty cool. Now the syntax is the rule name followed by the keyword returns, followed by, in brackets, a comma-separated list of types and identifiers. Immediately after this, we start our rule with the colon operator. What was that?
Oh, no, nothing.
Oh, okay. So I'm not going to worry about object just yet because object gets a little funky. But I am going to go ahead and add support for arrays and literals. The way I'm going to do that is I'm going to start with the literals because that's the easiest one to deal with. And I'm going to add some actions right here that will return us a value. But here's the problem. Well, first of all, I'm going to add a returns I value builder to the literal. And then finally, I'm going to set the result of the literal iValueBuilder's return type to the values builder return type. Now I'm going about this a little bit backwards, but I'll explain it all in a second. And then our file, what we're going to do is we are going to say builder equals value.builder. Okay, so I know I did that a little bit backwards, but let's walk back down the stack here. So we start with our file rule, which is our top level rule. It's going to go ahead and set the builder member. So this is an actual member of the class, which is why I don't prefix it with a money sign. And we're going to assign it to whatever the result of the value return type was. And the return value is going to be in the variable builder attached to the value rule. Remember, wherever you see the money symbol in ANTLR in an action, ANTLR is actually going to take this identifier, match it with whatever it matches with. In this case, it's a rule right here, and replace it with the actual object that's returned by that particular rule being executed. So finally, our value, it returns a builder, but only in one circumstance. So in this case, you'll see that this action is actually tied to a particular, what's called an alternative. Every one of these things is an alternative. Alternatives are separated by the pipe symbol. So this action will only execute when this final alternative is matched. In this case, we're ignoring object and array for the moment, so if ANTLR was to parse these, it would return a null builder. Now you see, this is how you set return values. You simply reference the name of the return value, prefixed by the money sign, and assign it to, well, whatever expression you want. In this case, it's going to be the return value of the literal rule. So now we have to pretty much do the same thing here under our literal. So what I'm going to do is, I'm going to say a number is going to return builder equals new constant builder, because that's going to be for all of our literals, float.parse number.text. Now, when you're dealing with a lexer rule, .text is going to be the property on every parser rule that returns the text of the token. So pretty straightforward. This one's going to get a little bit more complex because we have to actually chop off the two string literal characters. So we're going to say string.text.substring 1, comma, string.text.length -2. So in this way, we will chop off the first and last character from this string token's text. Now the identifier, I actually don't want this to be parsed out. I realize that. I'm actually going to be modifying the grammar a little bit here. I want the literals true and false to correspond to the constant of true and false. So what I'm going to do here is I'm going to define two new parse lexer rules, and this brings up an interesting point. Because identifier will match the keywords true and false, I have to declare my true and false tokens lexer rules above the identifier lexer rule, because the lexer rules will be matched in order that they're defined. So let's start with true, and say true is the string literal true, and false is the string literal false. Now, I don't like this very much. The reason I don't like this is not case insensitive. So let's go ahead and do some repetitive grunt work to make this case insensitive. And I'm going to be doing so using fragments. I basically want to make a fragment for every one of these characters that matches either the uppercase or the lowercase character. So I'm going to start with a fragment T, and fragment T will be either T or T. Then I'm going to do a fragment, actually I'm going to copy and paste this a few times. Yeah. Then I'm going to do R, U, E, F, A, L, S. So that should cover all of our characters. So let's do R, U, E, F, A, L, S. And finally, R, U, E, F, A, L, S. Okay, so make sure you get this all written down. And finally, we can now rework our true and false tokens to match T, R, U, E, and F, A, L, S, E. So now we have a case-insensitive true and false. So what do we do about this alternative? Well, let's go ahead and do it true, and then create another alternative for false. So now we can simply say our builder return is going to be, in this case, true. I just noticed a bug, so I'm going to fix that in a second. You guys probably already noticed that bug, but yeah. True and false. So we have our literals here. Now the bug I'm referring to is we don't want to float.parse that. That would be bad. So take off that code, hit Control S, and we should be good. So now on line 14, we apparently have an error. And the error is that that's not spelled correctly. So make sure that you spell that correctly to the to whatever the return name of the value rule is. So now I'm going to do arrays. We're not going to do objects in this video because objects introduce another interesting discussion, but arrays are pretty straightforward. And to do that, to do arrays, we're simply going to do a little bit of grunt work. I'm going to wrap this, I'm going to go ahead and format this differently for now. And I'm going to do that, then I'm going to do that, then I'm going to do that. And we're, like I said, we're going to do a little bit of grunt work right here, where we're going to wrap this in parentheses so that we can add on a nice little action that will only be executed if a value is found. And that action is simply going to append on the builder for the value rule onto our array builder, which we haven't even instantiated yet. So let's go ahead and do that first. Array will returns a value builder called builder. And it's going to have an action at the beginning of it called builder equals new array builder. And the first instance right here, we're going to say builder dot push value dot builder. Sorry, builder. Actually, that's going to cause a problem. We're actually going to have to do some more nasty stuff in here. Because the type of builder is going to be an iValue builder, not an array builder, we're going to have to go ahead and cast that. But I really prefer this over actually changing the return type to an array builder. So then we're going to copy and paste this rule and stick it in here. And we have one more problem. So now it's time to introduce another interesting feature of ANTLR. And I'm going to pull over my tool right here to show you what the problem is. The problem is basic JSON.g on line 33. Value is a non-unique reference. It's also on line 32. So what that is saying is that ANTLR has no idea which one of the value rules to match. Is it this one or is it this one? Because they're both going to be the same rule name. So we need to somehow alias out each individual ones of these rules into their own little variables that we can access. So I'm going to go ahead and do that with that. So by saying identifier equals rule in ANTLR, we're aliasing out the rule into a variable that we can reference inside of our actions uniquely. And I'm going to do the same here. I'm going to say b equals value. So now instead of doing value.builder, I'll do a.builder. Instead of doing value.builder here, I'll do b.builder. Hit Control S, and we get a successful compilation. Finally, on our value rule, we're going to have to assign our builder return type to our array.builder return. Finally, if I hit Control S, we get a successful compile. So now if I hit Control Shift B, what we get is another successful C# compile.
Sweet.
So again, objects are going to introduce an interesting problem that we're going to have to figure out. But for right now, we have our builders being properly instantiated for arrays and literals. So that's pretty cool.
Mm-hmm. Okay. So that's going to pretty much wrap things up for this video, and we will see you guys in the next.